do a short version of this Oreo lab and record that, and you can use that for your data if you don't have the Oreos or you're at home. I'm recording this on July 3rd, so I don't really know what next year is going to look like, but my kids have a tendency to, I buy these and then they eat them and I have to go buy them some more and more. So while I still have them in the house, that's why I'm recording this now, even though I don't know exactly what we're going to do with it. All right, so you want to have a kitchen scale that you have in grams, and if it's in kilograms, that's okay. You can just convert it. So I did that previously. All right, so I'm going to test the whole Oreos first, and you could do this however you want. We're interested in asking the question. I should have this written up more formally, which you guys will do, but our question is going to be, do double stuffed Oreos, are double stuffed Oreos double stuffed, contain double the filling? That's our research question. And our null hypothesis would be that there is not a significant difference, or not double stuffed. That there's not double the stuff. And your alternative hypothesis would be that whatever you think. So I'm going to say that my alternative hypothesis is that the Oreos are double stuffed. And you're going to hear somebody is mowing their lawn. I could close the door, but it's really hot. I have a tendency to do my work in the garage so I can get away from my kids and such. All right, so there's a number of different ways that you can do this. What I'm going to do, because I'm lazy, is I am going to weigh the whole Oreo, and then I'm going to weigh the wafers, and then I'm going to subtract that to get the filling. That just makes the most sense to me, especially since it might be hard to kind of totally retain all that filling. And I'm going to test, the reason I'm going to test 3 in this is because this one has 6, as you can see, but this one only has 3, so that's why I'm picking 3 to do. And then we're going to compile our data together. All right, so let me start with the regular, and I should have some of this to be, so I don't have to put it on the scale by itself. I don't want to munk up my new scale. Make sure that you zero it out. I never used this one before, tare. Okay, so it says 0. I'm going to do my regular first, and so I'm going to weigh the whole cookie in grams. And again, make sure you're in grams, and that's 11.43 grams. And then what I'm going to do is I'm just going to then weigh the wafers. So make sure that they're pretty clean. I'm just going to do that. You can weigh them separately, but I've seen different tables with that, but I don't think that's necessary. And then I'm going to clean off as much of the filling as I can. You can do this with a knife so you can preserve it without getting it. So, I mean, like I said, there's different ways of doing this. If you want to be more precise and try to just weigh both, that's fine, but I think I'm just going to do it by subtraction. I think I'm going to get the most significant amount of it off of there. All right, so then the weight of my, gotta be careful because I'm on this little folding table, 8.49. So I left my calculator in the house, unless I can find one. I might be able to find one in the garage. Okay, so I found a calculator. So I'm going to do 11.43 minus 8.49 gives me 2.94 as the amount of filling for that 1 Oreo grams. Okay, so now I'm done with that one. And I'm going to do the next one. And I'm going to try to ignore, I think that's my husband cutting the grass, so I guess I can't be too mad. All right, so whole cookie. Make sure my tare is 0. Okay, and then that's going to be 11.74. And then I'm going to get rid of the filling and just take the wafers. You could lick them if you want. I'm not going to do that on camera. It's probably cleaner, probably more accurate. So we're just going to do this as like a way of learning some statistical, making this messier than it needs to be. Okay, and then that's 8.78 is my wafers. So 11.74 minus 8.78 gives me 2.96 grams as my filling weight. Okay, and then the last one for this batch, I've got to do the whole cookie, and then 11.66, and then my grams on my wafers. Try to get these as clean as you can get them. Again, you might want to just lick them. That's one good way to do this. I'll try not to get .76, so we have 11.66 minus 8.76 equals 2.9 grams. Okay. I don't want to eat too much of this, but I'm going to try a little bit. Okay. So that's my regulars. You can do with what you want for those. You can see why I wanted you guys to do this at home, because we shouldn't be eating stuff in the lab. All right, so now I'm going to start my double stuffed. My whole weight of my first double stuffed is 14.70 grams, and get as much of that filling off as possible without cracking up your cookie a million times like I did just now, but it shouldn't matter, except for the crumbs. It'd be negligible. It's a good word for us, negligible. And that's 8.52 grams. So if I calculate that, 14.70 minus 8.52 gives me 6.18 grams. Okay. Whole weight is 14.65, and the weight of the cookies, the weight of the cookies minus our filling. Oh, I'm just terrible at this. Is going to give us 8.51. Oh, it did say, I thought 8.51. What? Did I lose a big crumb here or something? No, now we're all over the place. That's not good. what is happening? 8.52 grams. Okay. And then, so that would give us, I think I know, but let me just double check. 14.65 minus 8.52, 6.13. All right, and then last but not least, we have our third Oreo weighing in at a heavy 15.03 grams. And then just of my wafers, no, it's not a good place to wipe it. The filling tastes different on these. I thought that was weird. I always thought I loved double stuff, but when I did this experiment before and tried them, I did not like the double stuff filling as much. So we have to see if you find out that same thing or not, or if I'm just not with it here. All right, and then an even 9.00 grams. So those are so different. That one was different. 15.03 minus 9 gives me 6.03. Had a lot of filling. Oh no, not as much. Oh no, the wafers weighed more. Okay, so that's the setup for that experiment, and then I will continue with this video when I go to make the spreadsheets. GoPro, stop recording. Okay, I put my values into the spreadsheet here, but I think I got something wrong here. Let me look. This is my mass of my wafers. 8.52, 8.529. 4.7, 4.7. Yeah, this one looks like this one should say 15.03. Let me double check these. 14.65, 14.7. My kids actually did this experiment, so I have their data. I'm going to have you add your data to my pool, so you have the 4 sets of data. And then we'll do this in class with more sets of data. I just want to double check, make sure this is right. All right, so I already did on the camera the subtraction of the values, but I want to show you how you can do that on the spreadsheet if you didn't use a calculator to do that. It's much quicker to do it this way. So this is where I want my mass to go. So I am going to put in a formula by going to that cell and hitting equal. And I just want to subtract these. So the easiest way to do that is to go to, it'll be B3 minus C3, okay? And you see it highlights the values, and then it'll say the 2.75, so that makes sense. I just want to double check my numbers to make sure they make sense. So now I could do that for all of these, which, I mean, I can, but see this little square? All you have to do now is pull that down and it will calculate it. I just double check it again to make sure, because sometimes you get some weird stuff happening, but it looks like all that makes sense. So the average would be 2.9, so just under 3. All right. So same thing here. I want to subtract, so I'm going to go to equals, and that's going to be E3 minus F3, and you see it highlights it to make sure that's right. And then it's going to be, let me make sure that's right, 3.5, okay. And then I'm going to just pull that down here, and then I get all of my values. All right, so what I want to do now for average is I'm going to do the same thing down here. I'm just going to go to equals average, and I'm going to highlight those values. What happened here? Sometimes weird stuff happens. Equals average, and I want to highlight my values, and that's not working. Why not? Spreadsheets, they're love-hate with spreadsheets. Equals
And it's going to be B3 and through B11. So I must have done that one already. And 11.59 is going to be the average, which looks like it makes sense. All right. So now I'm going to just pull that over. 8.44, mass of my filling, 3.16. Okay, these numbers are looking like they're making sense to me. 5.62. Okay, so it's not looking like it's quite double. So let's see if it's significant, though. That's what we're going to use the standard deviation and the standard error of the mean for. So you always want to refer to your formula or your AP Biology formula sheets for these, but you want to understand what you're doing and what it means. So standard deviation, and here's the formula for it, is going to be the sum of each individual value minus the mean squared divided by the number in the sample size minus 1, and that's called the standard deviation. That's showing you how much spread you have in your data. So how much each individual value, and add them up, differs from the mean. And then the standard error takes into account the size of your sample as well. So both of these values are going to help us determine if something is results are significant. Okay, so what I'm going to do for standard deviation is I am going to use the formula they already have in here instead of doing each one of these. We're going to probably practice on some practice problems that are a little bit smaller than this. This is not a huge data set, but I don't want to calculate all of these standard deviations. So what I'm going to do is I'm going to go to equals and start typing in ST, and you see standard deviation comes up. It's a very common one that you use. And then I am just going to highlight all those values, put it in parentheses, and hit enter, and 0.19. That looks like a standard deviation. And then now all I have to do is pull that over and see if that makes sense. Yeah. Okay. I could pull all of them over, and these are my standard deviations. All right. So the next thing is going to be the standard error of the mean. And all you have to do for that, and that's going to help you when you do your graph, you're going to plot your graphs with error bars 2 times the standard error of the mean. The abbreviation for that is SEX bar, standard error of the mean. So that X bar meaning the mean. All right, so I don't think there's a formula for that. There might be, but what we're going to do is we're just going to take this square root of the number in our sample size. Well, this one we happen to get lucky with because you in this one you're going to have 9, but in yours that you're going to do, you're going to have at least 12 sets of data. So you're going to take the square root of 12. You're going to take the standard deviation divided by the square root of 12. Ours is going to be all divided by 3 because there's 9 in my sample size. Square root of 9 is 3. So what I'm going to do here is I'm just going to take this value. I'm going to do B13 divided by, oops, I forgot my equal sign, equals B13 divided by 3. Okay, so that looks good. And then all I have to do then is drag that over. Okay, now when I graph my standard error, I'm recording, bud.
Can you spell Minecraft?
All right.
I can't be in here.
No, I'm recording. Okay, so these are the values that we're going to need when we do our graph. So, and I just pulled in this because this is our formula sheet. Okay. So for my graph, I want to graph my mass of the, I want to graph the average of my filling. Let me just, we can copy these values. Okay, so I'm going to say that I'm going to have regular and I'm going to have double stuffed. And I am going to put in my regular average of the filling, and edit. I want to copy, and then here I want to paste special. I don't think it really matters here, but I want to paste my value only. Okay, does that make sense? 2.16. Okay. There we go. And I want to, my double stuffed value is 5.62. So it doesn't look like it's quite doubled, right? No. So I don't know what happened. Hopefully when you guys put yours in, because when I did this before without the second set of data, oh wait, this can't be my average. Why does that look weird like that? 5.62. Oh, maybe it is. Maybe they didn't do something right when they, because mine look like they're doubled. If I have more Oreos, I might repeat this. I got a different scale than they had. But right now they don't look like they're quite doubled, so I would have to reject my alternative hypothesis. But when we graph this, we need to graph our standard error of the mean, and you're going to do 2 times that. So I'm going to just kind of keep those up, and I'm going to highlight this, and I'm going to go to insert chart button. Oh, I don't want a pie chart. Nope, nope, nope. I want to have one of these bar graphs. And I like to make a different color. Maybe like your double stuff, regular color. Oh wait, how did I do that? Okay, so how do I get it so they're different colors? You gotta, yeah, there we go. All right, and then, nope. You got to play around with these to get it where it looks like you want it to be. And then I am going to flip this. I want this one to be this color, and I want this one to be blue. It doesn't matter what colors you pick, obviously. But we have a big problem here. We need to have this. We don't want that, of course. Item can't be deleted. Oh, I want it deleted. I want delete chart. Okay. So when you plot your error bars, you need to do 2 times the standard error of the mean. And I believe they will show you that on the, they will tell you that on the, when you're doing a free response question on the AP, but that's going to be what we're going to do here. So we need to find the error bars on the, see here. So I went to series or chart axis format. Okay, so here's my error bars, and we need to add a constant value, and my error bars for my regular, I don't want it to apply to all series. I want my regular ones here, and my error bars have to be a constant, and my value on that is going to be 2 times the standard error of the mean. So this is going to be 0.12. Okay. Error bars, not percent. That doesn't look weird. Constant. 0.12. Oh my goodness. Not percent. Constant. All right, and then my next series that I want to do here is my error bars are not going to be 10. My error bar is going to be 2 times the standard error of the mean for that, which is going to be 0.26, a constant. Okay, so that looks good. And these are significantly different because my error bars are not overlapped, but they're not quite double because it would be 3 versus 6. Okay, and then I can move that to a place that it looks. I should put I should put a title on here, and my chart title is going to be regular versus double stuffed Oreo filling. And then let's see here on my series, my horizontal axis, I can try to type this in horizontal and label font labels. Okay. Series labels. I want to do my axis title. Okay, I want to have my horizontal axis title. I can put a regular and then double stuffed. This is not really necessary because you have in your legend. I think it looks fine. So sometimes this can be finicky to try to get that to look right. But I think that's fine. And then my vertical axis title should be labeled grams of filling. Okay. And there we go. Now we have a nice chart that looks good. Has our error bars. That's very important. So if your error bars are overlapping, then that means there's no significant difference between your two groups. In this case, our error bars are definitely not overlapping, so there is a difference between the amount of filling that's in a regular and a double stuffed Oreo. However, it's not double according to this data. Again, I might redo this data a little bit. I'm probably not going to re-record it, but when I give you the data to add your data to, it should hopefully look different. But I was using a different scale, so you want to be able to make sure that you can measure in fractions of grams, where mine was just doing in grams, so I kind of had to deal with that. And that's it. So that's how you use Oreos to work with things like averages, standard deviations, standard error of the mean, and how you plot that to tell if there's significant differences between your groups.